we'll go ahead and get started for the sake of everybody's. I just wanted to start out with a few slides to introduce those of you who aren't familiar. It looks like most people here in the room are familiar with what we do here at the lab, but for anybody online that doesn't know anything about the University of Idaho Integrated Design Lab and what we do, just a few slides. The current lab is made up with of this group of folks. We've got engineers, mechanical engineers, architects, graduate students in both architecture and mechanical engineering, and we are dedicated to the development of high-performance buildings here in the Intermountain West and really throughout the region and hopefully throughout the U.S. And that includes development of energy efficient, healthy, and productive buildings. We do that through research, education, and outreach. So really interesting work, a great group of people. This BSUG, as well as a number of other projects, are funded generously through Idaho Power. This is their Idaho Power Commercial and Industrial Efficiency Program slide. If you go to their website, which is listed here, you'll find additional information about these specific programs. Some really wonderful opportunities for incentives and for assistance, and a lot of times they'll lead you back to us. So like that. Another product or project that we have here that we'd love for you guys to check out is the building metrics labeling. Really great downloadable PDF file that can show building owners or managers information from energy usage to walkability to daylighting, information that could be useful to potential tenants as a green lease sheet, or just to know a little bit more about your building and doing some goal setting and benchmarking. We also have a really robust tool loan library. We can measure everything from energy and power to sound, temperature, luminance levels, air velocities, all sorts of fluid measurements. All of these tools are available and free to people in the Idaho Power territory. We've got about 900 separate tools at this point, and we are now adding ASHRAE handbooks, manuals, and guidebooks, so you don't have to spend the $500 to buy the book that you may use once. So those will be coming online shortly, so keep your eyes out. And here we are today welcoming Kara, is it Lagios? Lagios, okay, so hard G. I've been saying it wrong this whole time. Lagios. But next month we've got David Bradley, who will be talking about modeling in Transys. He's got quite a bit of background in both Energy Plus, eQuest, Do2, all sorts of different whole building energy systems, but he's going to specifically talk about Transys. So if you've ever had any interest in that as a tool, stay tuned for that. And then we'll be posting the next speaker and the speaker date to come. I'm going to try to coordinate with ASHRAE for a distinguished lecturer in September. So look forward to that. So I'd like to please also don't forget to sign in because another thing that we're doing is for those of you who are able to attend 3 or more of the BSUGs this year, you'll be eligible for a door prize at the end of the year. 4 or more, you get eligible for both. Basically, you get a double chance. So definitely worth signing in. And we'd love to get your feedback. So if you have a chance to fill out the evaluations, we'd appreciate it. So we'd like to welcome Kara Lagios, who is visiting us from the San Francisco Bay Area. I think you're in Oakland now.
Yes.
And your background is both in daylighting and lighting.
Correct.
You're working one of the co-founders, right, of Solema?
I'm one of the co-founders, yes,
so,
that's correct.
tons of experience and a lot of work in helping to develop Deva for Rhino. So we can't wait to see what you're going to show us. So
Great.
Thank you.
Thank you. I think this is working. Yeah? Great. And we'll just get the slides up here. Okay. And let's see if this is working. So it's working on there, not here. If I do this, does it? No.
It did that to me too. It only showed, they only switched one or the other. It didn't switch both.
Okay. So let's go to
Nope, there we go. Working. Okay, thank you so much for having me. Thanks, Elizabeth, also Sandy and Layla for suggesting that I come by. It's very exciting for me to be here. I've heard a lot about the IDL from Kevin Van Mellenberg over the years through sort of Radiance conferences, and he was at Deva Day in Seattle a couple of years ago. And your setup's quite fabulous. I was admiring the skylights with the different specs written on them, and I'm envious of your setup here. So again, my name is Kara Lagios. I am an associate principal at Integral Group in Oakland, and I'm co-leading the Integral Light Studio, which I'll talk about in a minute. I'm also a founder and developer of Deva for Rhino. And previous to my work at Integral Design, I was a daylighting and lighting designer at Lam Partners. And I also hold a Master's of Architecture from Harvard Graduate School of Design. So my background is in architecture, and I sort of but always had an interest in environment and building performance, and I sort of, that translated into daylighting and my work with Deva, and then has expanded to sort of encompass all lighting, so electric lighting and daylighting. A little bit about Integral Group. If you don't know about the company, we are a deep green engineering firm, about 300 plus employees, and firms in the US, Canada, and the UK. We're focused really on net zero energy buildings and sort of all factors of it. So we have mechanical engineers, electrical engineers, plumbing engineers. We also have a sustainability department and the light studio now. So that's that. And then just to talk for a second about the light studio. This is sort of a new initiative that we're starting at Integral Group in the Oakland office, and so it's co-led by myself and Mike Martinez. And we really, this image sort of represents the fact that we really are looking at both and electric lighting, that those two things really, it's really about the visual environment and not specifically one or the other. Let's see. So today, actually, I'll go back a second. You probably, as Elizabeth alluded to, if you have heard of me at all, it's probably in connection with Deva. I was one of the original developers of the software. Earlier this year, I stepped away from my role as a developer there. I'm still part owner of the company, but I wanted to focus on some other endeavors. However, I'm happy to answer questions about Deva. Deva Day is coming up in Toronto in September, so if you have questions about that, or if you're interested in attending, you're also welcome to give me provide. I'm happy to provide some information about that. But actually, I decided to, as you saw in my summary, I decided to sort of go with a little bit different theme for this talk. And that is actually electric lighting, because I feel that electric lighting actually has sort of gets a little bit shortchanged when we're talking about building and building information modeling. It's actually a really important part of what we do, and part of the reason that I think we haven't engaged with it as much up till now in the building performance and modeling community has partly to do with the fact that it was very difficult to model, or it was modeling it sort of didn't provide great results. And also back in the past 20 years or so forth, lighting power density and energy usage wasn't as critical an issue. It was, we had more freedom to design sort of with whatever we wanted to and achieve the lighting power densities that, the sky was the limit. So these days, especially in places where I live like California, we have very restrictive requirements about lighting power densities. But also research has sort of advanced in terms of the value of light in our spaces and the importance of not just daylighting, but also electric lighting design. And so in terms of the focus of is shifting a little bit, and you'll see in things like the WELL standard or even LEED v4, you're starting to see there be topics that really focus on things like the luminances of light sources, for instance, and talking about electric light sources. So I think this is a topic that sort of hasn't gotten as much attention and is sort of worthy of some of that. So I'm going to sort of go through an overview today of some of the ways that electric lighting has been integrated into various softwares. Part of that will be how it's integrated in with Jeeva, as well as some other things. And it's meant really to be kind of an overview for people who may not have ever dealt with electric lighting in a software before, or at least in the kind of ways that I'm going to describe here. Okay, so why electric lighting? I described a little bit of that before, but also you can see on the left of the graph from the DOE in 2002, you could see electric lighting was about a quarter of the energy use in commercial buildings, due partly, I think, to the fact of LEDs, some other energy efficient measures. Now in 2012, that's been reduced to 10%, which is great, we're moving there, but it's still a very large percentage of the energy use in our buildings, and it's quite well, I'd love to have buildings that were fully daylit all the time, and you guys have a pretty great setup here. There are very few buildings that don't have electric light in them at all, right? You basically, especially if you're going to have occupancy at night, you need to have electric lighting. So really understanding what we're doing with that valuable part of our space is quite important. The other thing is research is starting to appear more frequently and more urgently, I would say, about the effects of electric lighting in our environments. So the AMA, American Medical Association, just came out with this community guidance paper or guidelines about street lighting in particular and blue street lighting. Now, various lighting design organizations or lighting organizations have come out sort of with some counter arguments against some of what the AMA has put forth. It's also interesting that the AMA doesn't seem to have contacted anyone in the lighting community when they made this these guidelines. But the thing I want to point out is that lighting, really electric lighting specifically, is just becoming more and more of a topic that we should pay attention to in our designs. And in some cases, it's being asked of us in terms of the WELL standard. If you are familiar with that, there's one of the sections, credits, I can't remember what they call them, that has to do with melanopic lux or circadian lighting. And although that pertains both to daylight, it also has an effect on how we design our spaces for electric lighting. So, and then other things about electric lighting, there's a very strong visual component. So what you're seeing here, this is some of the electric lighting work that I've done. These spaces there's an energy component, there's a health component, there's also a beauty component, a visual component to the way these spaces look. And the way our spaces make us feel and the way we inhabit our spaces is a very important factor along with everything else. So, and really when we're talking about light, while envisioning light levels in this form of point grids and so forth is important, it's also important to understand really the visual environment, sort of what that looks like, what contrast ratios are like, et cetera. So in terms of daylighting versus electric lighting, just an overview of simulations and what the challenges are between the two. For daylighting, you have one source, it's the sun, and it's a computer-defined sun and sky with a temporal component. So it's obviously very important that the sun, as it moves across the sky during the year and throughout the day. But it's also critical to solar gains and facade development. So we tend to gravitate and use daylighting partly to form our spaces, and that's part of what makes it really exciting. In terms of electric lighting, you have many sources, and you have manufacturer-based IES files that form the basis of your simulation. You also have color temperature, which is an issue, so what color the light is, your light source efficiency, wattage limitations, and the appearance of the luminaires. In terms of electric lighting software, there's kind of a range of things out there that you can use. So everything from AGI 32 to Radiance, 3D Studio Max, Deva, something called the Lume Tools, which I'll talk about. And even things like OpenStudio have built Radiance into their engine, and so you can actually do some simulation through that as well. One of the major things to know about simulating lighting versus daylighting is daylighting tends to rely heavily on ray tracing software, whereas electric lighting has typically defaulted to a radiosity solution. So, so these are the simulation engines that depend on either ray tracing or radiosity. So ray tracing is sort of radiance, and then the softwares that use radiance behind it. So that would be Deva, Honeybee, OpenStudio, and ISV has some of that in there as well. And then 3ds Max has its own ray tracing available. Radiosity is used a lot by lighting designers, partly because it uses well, I'll explain what radiosity is in a second. So, so ray tracing is a time-consuming way to render light. It's view dependent, but it is very highly accurate. You can accurately model materials. It really allows you to capture sort of the full luminous environment very well. Radiosity, on the other hand, is fast. It's not view dependent, so that means you can spin around in a model once you've calculated it. But one of the main drawbacks is that all surfaces are modeled as a Lambertian surface, so they're modeled without specularity, and that's a significant drawback to the radiosity environment. But that's part of the reason that it goes so fast. And then IES files, they are what they form the sort of the backbone of any sort of lighting simulation. IES files can be downloaded from the internet, from manufacturers' websites usually, and they basically describe all of the factors that you need to accurately model luminaires in the computer. And so some of the stuff that I've written on the side here, I hope that you'll be able to use as a reference in the future. I know that the presentation will be posted online. And so I really wanted this to be sort of a resource for people who are not as familiar with electric lighting to go to in the future and sort of use it as an active resource. And so that's what I put all this stuff here. So hopefully you, if you have questions, of course, ask them now, but also please go ahead and and reference this in the future. So anyway, this is what a typical IES file looks like, and the information in there is basically it's more or less a Candela values table, and you can use it to define how the distribution of the light comes out of the luminous source. So one of the first topics I'll talk about is Revit and Illume Tools. So this is a plugin for Revit that allows you to do electric lighting calculations all in one bucket, and it's pretty powerful, and we've started to use it in our practice. Lighting analyst software includes AGI32, Photometric Toolbox, and now Lume Tools. It's a radiosity-based engine, and basically it's what you use if you're going to do large-scale lighting simulations. Daylighting is available in it. It's somewhat limited at this point, although they are going to be introducing climate-based metrics component or additional feature, I think, pretty soon. That will still be radiosity based, but it will allow you to do lead V4 calculations within a Revit environment. So in terms of workflows prior to Illume Tools, you would have to build your geometry from scratch in AGI, which is software that the software we use. Build it in another program and import it into AGI, or import it directly from Revit and pray that it translates well, which sometimes it would and sometimes it didn't. And then you have to transfer information back from that model back into CAD or Revit. So now this is actually a Revit model. This is the view of Lume Tools. You can see that I didn't show a picture of what AGI typically would look like, but you didn't have anywhere near the amount of detail that you have in this now. So we're really able to, inside Revit itself, really be able to model these fixtures. And especially in a work environment, this is extremely helpful because, as you'll see, we can calculate lighting power densities from that very easily. Plus, we can get much higher quality renderings in a much quicker amount of time. So yeah, and so that's basically those are the advantages of it. And it's all in one package, and it goes very quickly, right? And you don't have to translate back and forth. You don't waste all that time. In terms of the infrastructure required, you need to set up spaces. You need to have your families, lighting families, and you need to actually have the Illume Tools plugin installed. And I think there are like trials that you can get for that. So again, a lot of this will be sort of stepping through the process, and I won't go through every single thing. But I hope that if you do intend to use this, you can go back to this presentation later and really look at this, because this contains a lot of the information you would need in order to get up and running with this up. Yeah.
So for the simulation, is it required to use their cloud services, or can you do
No, there's no. I don't know that they actually have cloud services for Illume Tools at the moment. They have it, for Revit, right? You can put things in the cloud for that, but I don't think Illume Tools has cloud. I could be wrong about that, but I don't think they have an interface yet. So if you're not familiar with Revit, one of the things you have to do is set up spaces. And basically that takes all of the rooms that have been set up in the architectural model and sort of binds them, right? It gives them a floor, walls, and a ceiling. And that's pretty helpful later. You can also do regions and stuff for exterior surfaces. Revit, there are a few sort of tricks to using Illume Tools in Revit, mostly based around how the spaces are defined. You need to make sure that the luminaires are captured by the offsets. Oops, sorry, by the offsets here. So, for instance, if your room is 9 feet tall to the ceiling, but it actually goes about to 10 foot to the deck, right above the ceiling, you need to make sure that that gets captured, that the luminaires are actually, so 9-foot offset might not quite capture it, because you need to go all the way up to 10 feet in order to have the luminaires inside the space.
You're saying room bounding, right? Room bounding would be above luminaire?
Room bounding is actually slightly different. So room bounding is part of the material properties, and the spaces are have to do with the offset. So room bounding actually has to do with whether your floor stops at the wall here or whether it goes beyond. And these are just things that you, depending on what you're trying to model and how much you're trying to model, you might either, well, in this case, actually, I'm sorry, you do need to have room bounding turned on. There's another example I'll show you in a minute. So the material needs to stop at the end of the room, basically. And this, I think, yeah. So then in terms of light fixtures, you need to, Revit has a whole bunch of families already set up. They have IES files that, or they have an interface already. So right here is the light source definition from Revit. And there's a photometric web option. You need to have that selected. And then you can see there's a whole bunch, there's an interface here where you can actually select the photometric web. Revit can put in a default one, but then this row right here is where you would select the IES file. And it's just like you click it, browse, go get the IES file, and then it comes in, right? Yeah. You have to initialize a project, activate the license, and Lume Tools will automatically add some additional information to your properties, to the light fixture properties that involve some things I probably won't go into, but there's information on whether the fixture is switched on or not, the dimming level, and whether it's being used for emergency. For material mapping, this is common, to lots of different projects. Typically, you have your geometry, you have your nodes or whatever you're going to calculate, then you have your materials, and then you have the calculation that you're actually going to run. Jeeva set up the same way. Honeybee is very similar that way. So when we get to materials, one other nice thing about Revit is the materials are already there, right? They're already established by the Revit model. And so you can go in and just use the materials that have been already defined, or you can override them. Lume Tools allows you to provide overrides to those materials. You can manage surface reflectances for the materials by going into the materials and changing the color. And then in terms of what gets calculated, that's where Revit's a little bit different than some other softwares, or part of our Lume Tools a little bit different, because you may not always want to calculate the entire building. You may just want to calculate one space. And this was something they struggled with when the software first came out, is how do you just bring it down to one space instead of the entire building. Also, how do you, with somebody else's model, how do you turn things on and off? And so in Illume Tools, it creates a couple of luminaire, or several luminaire views, 3D views. One is a luminaires view, which shows you all the luminaires in your space, and to know whether you, this is actually a troubleshooting measure, which allows you to see whether the photometrics are oriented properly. So this is a big thing to know when you first start engaging with photometrics, is you can't always depend on them to come into the model oriented perfectly. And I'll show you an example a little bit later. So photometrics, if you've seen them, sometimes they have, like, for pendant fixtures like the ones in this room, sometimes they have what's called a batwing distribution. And that actually means that the light sort of comes out like a batwing this way, and it shoots lights out the side, but it's not symmetrical about the center axis. It's different this way. So you have to make sure that the photometric is oriented properly with regard to the shape that you're modeling. Sometimes they're asymmetric fixtures, right? So they're pointing one way, and so you have to make sure there's some relationships there. So this is part of what allows you to troubleshoot that, and then you can go into the family and adjust the photometric relationship there. The other view is important for understanding what geometry you want to render. Now, you're still seeing the whole building. This doesn't mean that the whole building will be calculated. But for instance, if you want to turn off furniture, casework, things like that, things that will weigh down your model, you just don't want to model, you turn them on and off in here. And then you can also use something like the boundary buffer, which means that basically if you want to stand outside the room and look back in, and it's a little bit hard to explain, AGI and Illume Tools use sort of a, I'll go back here. This picture, see how you can see through the exterior walls? That's because the buffer hasn't been set very far, right? So it sort of trims out the walls so you can see through things. It's kind of a nice feature sometimes, but not that helpful other times. So the boundary buffers allow you to view interior spaces, or actually not for, it'll either allows you to view interior spaces from the exterior, or alternatively allows you to see the exterior walls if you want to. And then finally, setting up point grids, very similar to any way you would do it. It's based on the spaces or the rooms or regions that you set up, and you can set it up there. Very similar to other softwares where you determine spacing of points, etc. And then finally, the most fun part is the calculate button, which is this button right here. It has a pull-down menu, and you can calculate or ask you which rooms you want to simulate. And then actually this window just pops up and starts calculating your lighting for you right there. And so it all happens right within Revit, and it's quite easy, and it's really nice to have this right in the tool. So you move a light in your layout, and it updates in your model. You can rerun the model, etc. You can also view things in sort of the traditional ways in which we view them. You can do luminance maps, regular cutaway renderings, or you can actually view point grids, like the one on the right, this one, and that's grid-based point data. There's a few different ways you can view it, but it's really mostly available in floor plans in this way. You can see it in 3D views, but it looks a little bit different. It's not colored. Yeah. I think it depends on how the model is set up, how the Revit model is set up. But yeah.
So you can change where that plane is potentially.
Yes, you're not restricted to 30 inches off the ground or something like that. You can change that, and you, by extension, let's say you were doing something where it was like 5 feet off the ground, you could change that as well. You can also do vertical surfaces, etc., which is important for things like the well standard when you have to measure the. Actually, in Lead v4 too, you have to be able to measure the lighting on vertical, actually on the ceiling as well, for some of the credits. So yeah. So one of the other important things that integrating these features into Revit allows us to do is to stop counting fixtures. I don't know if any of you have ever had to do a lighting power density for a large building, but a lot of times it comes down to, especially if you have to do a space-by-space method, you literally have to look at the plans, count up how many fixtures are there, how long they are, if they're, runs, make an Excel sheet or whatever you're going to do. It's extremely time-consuming. If things change, and you might have to redo a lot of this work. And that's one of the great features of BIM, is it can automate this process. And but there are a few tricks, and I've noticed a lot of lighting designers even haven't cracked this nut yet. So if there are any listening online or whatever, they might find this helpful. Is that you can actually do it in Revit by generating a schedule. But the important thing is when you have your luminaires, you have to turn something called the room calculation point on, and that basically tells the fixture what room it's in. And it needs to be pointing, if this is the luminaire family, it needs to be pointing into the room. So if you can get that set up, you can, there's a couple other things necessary to do, but that will allow you to make, and that just will speed up things incredibly in terms of time. I mean, I don't know anyone who likes doing that. It's just one of the worst things to do. And, we shouldn't have to do that anymore. So, so now we're going to get into a little bit more of the visual environment. That was still more, very useful stuff, but maybe not as exciting as some other things. 3D Studio Max is actually still my go-to when I really want to produce something that is very high quality, but also accurate, because I really haven't found anything else that works quite as well. And you can actually do these kinds of renderings. Again, Revit models have made this a lot easier. 3ds is an Autodesk product. Exporting these as FBX files, or even DXF files. Basically, all you need to do, the materials are mostly already in there. All you need to do is add the luminaires. So a lot of that stuff that previously would take a lot of time in sort of translation, or would take a lot of time in redefining materials, things like that, have now become a lot easier for everyone to do. And it really makes doing visualizations like this a lot more accessible. This is a library I worked on, or I'm currently working on actually, and you can see we really, just looked at different options. I hope you can see it, it's a little bright. So 3ds Max is best for high quality photorealistic but accurate renderings. You can actually use different renderers in 3ds Max. You can use, it used to be Mental Ray. I think now they just call it iRay. I think those are actually the same thing, but I could be wrong about that. Mental Ray is actually very similar to Radiance in terms of the fact that it's a backwards ray tracer. So a while ago, Christoph Reinhardt and Pierre-Felix Breton wrote a white paper where they sort of like tested out the accuracy of that render, and they found that to be quite up to snuff. VRay is very pretty, but it's not quite as accurate. And like I said, it's easy integration with Revit models. It inherits materials, but it does have a complex interface for rendering. And I found that the less you tinker with the settings, the better off you are. So going in and pressing the render button, you're going to have much better luck than you sit down and try to fool with all the settings. I mean, there's some tricks to that, but I've always found that the more I try to tinker with it, the worse it gets. So, and I think part of that is just because of the complexity of the things going on there. So again, this is another just step-by-step of if you wanted to incorporate some of this into your workflows, how you would do it. The first thing you need to do is actually to create a light. And in 3ds Max, this is generally the most important menu right here. Up at the top are the Create buttons with submenus here. So I think it's, oh, sorry, the Create button is this first one here. And the third one over is a little light bulb. And you can select photometric here, or I think later down, photometric web down here. And you can select a target light. And then down here it says choose photometric file. So similarly, the way you did it in Revit, you'd pick the photometric file and bring it in here. And then it shows you the photometric file. And then it also gives you a bunch of options. You can change the color temperature. You can change the intensity. So if you want to add sort of a maintenance factor here. And you can also change the shape of the light. So for instance, if you have a pendant, a direct pendant, like one of the ones back there in your office over there, and you wanted it to be 6 inches wide by 4 feet long, right? You could make sure that it showed up like that there. This is a little bit hard to see, but it goes back to the issue of whenever you're working with photometric files in any software, the orientation needs to be relative to the light body, right? So sometimes that's not correct, so you always have to pay attention to that. And then the other thing to keep in mind about a lot of softwares, this isn't quite true in Revit in the same way, but the IES file is actually separate from the Luminaire hardware, the Luminaire equipment. So you actually have to model the Luminaire equipment separately and then put them together so that they, you don't have to. Some people don't need to actually model the image of the pendant or whatever, and you just have the light source. But otherwise, you would need to actually model that geometry. And then you can use this link feature here to link the geometry to the light fixture, and that will allow you to sort of aim the fixture, as you pull the target around.
Just a quick question.
Yeah.
On the IES files. It's been a while since I've looked at them. The IES files for linear fixtures, can you modify the length of that, or are you pasting in like?
That's a really good question, because that is changing the outputs and by entering the length of IES files is one of the trickier things in all software. So so for what he's saying is if you scale that, if you scale, oh no, that's not it, the rectangle, the light here, and let's say it comes in at 4 feet and you scale it and you want an 8-foot fixture, right? It's not going to automatically scale the lumen output, right? It doesn't, actually, Illume Tools, none of the softwares are smart enough to know that when you do that, that's what you are actually asking it to do. So you have to manage that yourself and go in and change the lumen output. In this case, you would probably change it here in the resulting intensity. That's what I usually do. So I would go ahead and I would say, okay, I want 200% times 0.88, which is the maintenance factor. Yeah. So that is true. Sometimes also IES files don't come in all of the options that you want. Sometimes you go to a manufacturer and they'll only have the 4-foot diameter fixture, and you have this, 3-foot diameter fixture, right? And so you have to scale the lumens based on the output, right?
Yeah, because it would be like for the fine light or something. You're doing a custom link.
Exactly.
Placing it around whatever dimensions it is.
Right. So you do have two options. You can, if you're only 4-foot sections or they're only modules of whatever it comes in it, you can definitely just tile them or array them, copy them, until you get the length.
So you can tile,
but you can't, if you need an odd length like 3 feet, or you want a 6-foot fixture, right? You can't make 2 4-foot fixtures be a 6-foot fixture. So you either have to make a 6-foot fixture and factor the lumen output by 150, or you can make a 4-foot fixture and a 2-foot fixture and factor the lumen output by 50%.
You usually just follow a linear line so if it's 4-foot usually and a 6-foot one that I have custom, then I just 50%.
It depends on the software and what I'm trying to do. If it's important the way it looks, sometimes if it's important the way it looks, I might do the 6-foot fixture. It's sort of the same amount of work no matter what you do. It just depends on the circumstances. But yeah, that's one of the trickier things, and it's easy to forget too, right? You're going fast, because not as much in 3D Max, but in Revit, it would be the same in Deva, which I'll show you in a minute. Also Honeybee and stuff. You also need to change the wattage if you're depending on the wattage to tell you the amount, right? So hopefully one day all the softwares will get smart enough to know that you link the length to the output and the wattage, but right now they're not. So that's a very good question. Okay, so, and then I just want to show you this. These are some important things if you do actually go into 3ds Max and you want to use this workflow, because if you just press render, you'll get some weird results. You need to do two things. It's very hard to see here, but there's something called the exposure value. You want a lower value for lower light or nighttime scenes and a higher value for daylight or outdoor scenes. What usually happens is it defaults to 16, and you run your nighttime simulation, and it's like, it's like a blown out, right? And you're like, I don't know what to do. So you want to make sure to change that. The other thing is if you go back here, this actually, it's hard to see, but this says Kelvin. So this is the color temperature of your fixture. So you can put that in. You can say 3000 K. But that's relative to a white point that's set in the file. And again, it's hard to see, but right here it says white point, and I wrote up here. So you can use, so if you have it's a little convoluted. You could just leave the light at 6500 K and not touch the color temperature of the actual light source. And then it uses the white point, whatever the white point is set at, as sort of your white, right? So if you have the white point at 6500 K and the correlating color temperature of your fixture at 6500 K, they will look white when you render the scene. However, if you have them at 3000 K and you have your white point at 6500 K, it's going to look extremely warm, like by contrast, because it's saying that white is 6500 K and 3000 K is much warmer, which is actually true, but you'll want to adjust that and play with that a little bit. I usually start out, set it for the color temperature of my lights at 3000 and then adjust it so it looks a little bit warmer or cooler as I want. Okay, so going into Jeeva, excuse me. Jeeva has actually two options for electric lighting modeling, and I'm going to go through both of them. I said I was going to sort of talk more about the visual aspects and some of those things, but I did want to talk about some of the other interesting features of Jeeva that actually involve electric lighting. So the first option is used with climate-based metrics, and what I mean by that is really daylight autonomy, any of those ones that go with the useful daylight illuminance, continuous daylight autonomy, SDA, etc. And the other one is actually modeling IES files. So the first option, what is called in Deva are the lighting module. That's how we refer to it. And it requires you to know what your lighting layout is and the wattage of the fixtures being controlled. But the lighting isn't actually modeled like we've been talking about. It's just represented. And you'll see how that works in a minute. It is also fast and fun in Grasshopper with Deva 4.0. And so that Deva 4.0 has a bunch of new modules which are speed up some of these processes. You can't actually model IES files in Grasshopper for Deva for Grasshopper, but you can do this first option that I'm going to show you. So the first thing you need to do is determine a lighting layout. And so this is just a facade here. It's not showing up very well, but with some desks. And this is facing more or less northeast. There's a building over here. This is actually our office. And you have linear pendants at where it says P1 here. And so in Deva, what you do is you select the, I thought I had a slide in here, but I can show you, I might be able to show you later, actually in the software, that you select the lighting module, and it brings up this, this menu here. And this is after you've set up your nodes. Have any of you used Deva? Oh, you have it? Okay. All right. I guess it's not surprising, but I didn't realize that. Okay. So Deva, do you know what it is? Okay. I will explain it to you. Deva is a plugin, or basically a plugin for Rhino that does daylight and energy modeling, primarily daylight modeling. And it was developed by myself and Christoph Reinhardt, Jeff Nemas, Austin Jakubiak, and John Sargent while we were still students at the Graduate School of Design. And basically what it does is, have you heard of Radiance? You know Radiance? Yeah. So Radiance, if you've ever tried to use it with command line, is pretty opaque, right? It's pretty hard to learn. It's kind of difficult. And what we really wanted to do was make it accessible to more people. And this was at a time of really nobody had, the closest thing was Ecotect. Ecotect, you could actually access Radiance through Ecotect, but there were so many individual steps, and you had to go export everything out to Radiance and then import it back in, and it was really quite difficult. And so we wanted to really make Radiance a lot more accessible to especially architects who wanted a reliable and accurate tool to use in their software package or whatever. And since we were using Rhino a lot, we developed this tool. And I can show you a little bit of that in a bit. This actually allows you to do daylight autonomy, daylight factor, illuminance-based metrics, et cetera, quite easily right in Rhino. Do any of you use Rhino? No. What softwares do you generally use for modeling? SketchUp? SketchUp and Revit, yeah. So SketchUp, I'm trying to think what I guess Sapphira. Do you know Sapphira? So Sapphira, I think, works with SketchUp. And I think maybe, I don't know.
Revit and SketchUp, I think.
Revit and SketchUp, yeah. Do they do daylighting? Okay. Yeah, so in terms of daylighting, I'm not as familiar. I don't use SketchUp quite as much so I'm not as sure what daylighting, but I know Sapphira works with SketchUp. What's that? Do you use it? Oh. Really? Oh, wow, that's fantastic. That's not easy necessarily to do. I mean, it's super, super powerful, but it's not easy to do, yeah.
So we're excited to see, particularly for students, coming in and because we're teaching them Radiance as our data tool.
Oh, great.
Other options are good.
Yeah. Okay, so, I can see now that I probably should have geared this a little bit more towards the Deva software, but I'm happy to stay and sit with you guys and give you a little bit of information about that if you'd like after this. I think my plane is at like 3 or something like that, or I have to leave at for something. So, or I can direct you towards some other tutorials and things like that. But it does depend on you have to be able to use Rhino. So it's a Rhino-based simulation program. So I don't know if you have Rhino or use it. Rhino, I love Rhino. It's a great modeling tool. And the other thing is, yeah, anyway, so that's very helpful. So I'm happy to show you some of that later. Going back to this, let's see if I can actually, at the risk of disrupting my presentation, will it go back? Did I just ruin everything? Damon? I should have asked before I went and did it. Oh, I'll do it. I think I'll have to do it later. But I'll show you. I will show you some of the features of the software after this. Here. There we go. Okay. So in Deva, you can, oops, sorry. You can set up nodes and materials, and then once you have nodes set up, you can actually, sorry, let's go back here. Just we're going back to you determine a lighting layout here. So you have, you've decided what lights you're going to use in your space, and you know what the lighting loads are going to be, so you calculate that up just manually. And in this case, for this grouping, we have 768 watts of fluorescent fixtures here. Actually, I think, oh no, I just included these. And then in this dialog box, you can actually select the nodes that you want to act as sensor triggers. So for instance, in a normal space, you have a photosensor that reads the light in a certain area. And so you select which nodes you want to be those triggers, and typically it should be the ones furthest away from the window or furthest away in the zone from the window. And so you select those using the nodes up here, and then you and then you can select the operation, whether you want it manually controlled, photosensor controlled, etc. And then you put the lighting power in and the lighting set point, so where you want the lights to be triggered. So like 300 lux is when you want the lights to come on, etc. And once you have that set up, you can go ahead and run a daylight autonomy calculation. And so this is that typical output that you would get from Deva in a floor plan here. So this is, the left is showing the lighting and daylighting results if you had no shading. So you just, there's no shading on the facade at all. And then you have the lighting results with shading here. And what I didn't show you was the shading module, which is very similar to the lighting module, but it allows you to determine how much of the time the shading is open over the course of the year. The way you read these flood plots is it's January through December on this axis, and midnight to midnight, you know, and then through the day, noon is in the middle, up to midnight again here. So the unoccupied hours are where it's dark because they assume the lights are turned off at that time. And then this can tell you the energy use based on your light levels. So for instance, if you have a lot of daylight, you know, the lights will be on less, right? And if you're using the shades, the lights will be on more, and you can see that reflected here. So you have a lower electric lighting here and a higher electric lighting use here because you're blocking out some of the light with the shades. And also see that the mean daylight autonomy has dropped slightly, and the colors have gotten more yellow instead of red here.
Shading algorithms.
Excuse me?
For the shades, what are the operational algorithms?
It's manual shades, glare. You can set it to be operated by the angle of the sun, or you can set it to a threshold watts per square meter in a very similar way to the way that you set up sensor nodes. So these are actuator nodes, basically. For the shading, I think for this simulation, I selected the nodes in front here. And so if direct sun hits those nodes, it triggers the shades to go down, right? If it's above a certain watts per square meter. So going back to modeling IES files in Jeeva, this is the option 2. So I mentioned option 1 was where you're sort of not actually modeling the lighting, but simulating the energy use of the lighting in the space. This is the Jeeva toolbar up here, and we tried to make it very simple with 4 buttons. So you have the location, which establishes your weather file. We have the nodes, which is sets up the sensor nodes. We have the materials, which map the materials on your geometry. And this materials button is actually also where the shading module, the IES module, the lighting module exists. They all live under that materials button, and then the metrics button. So when you use the IES file importer, you pull down this, you click on this metrics button, and you select import IES file, and it will ask you to look for the IES file, similar to the other softwares. You have to navigate to that. And that will generate this in the space here, and it will be located at the origin. And so I showed it here because it's not, it always goes to the 0 point, so then you have to move it into your space. So once you move the fixtures in the space and populate them, then you can actually go ahead and run a daylight simulation, and you get actually the electric lights right here in a radiance image the way you would. So it's basically using IES Chad to populate this space, but it's taking away a lot of the back end, which is quite difficult to do. I preferred using this method to doing it by hand in Radiance. We use Radiance a lot in our office, but this is a much easier way to get the lights in the model. Then I just wanted to mention Honeybee. So Honeybee is also a plugin for, Honeybee is actually a plugin only for Grasshopper. I don't know, have any of you heard of Honeybee? No? Okay. Honeybee is a Radiance and Energy Plus. It's very similar to Jeeva. It works only in Grasshopper. And again, it sort of acts as a translator for Radiance. It's extremely powerful. Grasshopper is still free as a plugin, and so is Honeybee. And Honeybee is also open source. I will also mention that Jeeva is free for students. So there's a lot of these tools should be accessible to, if you're a student, they should be accessible to you. So I'll just skip over some of this, but I just want to show you, Grasshopper can look a little daunting when you first see it because it just looks like kind of a mess of battery type looking things. But each one of these components basically allows you to give it input and then output, and it works by connecting, you know, this component to this component and this component to this component, and it works left to right. So what you're seeing here, these are the 2 daylighting components, I'm sorry, the 2 IES components for Grasshopper, and they take, I'll get into a second what they actually do. When you do use Honeybee and Ladybug, you need to actually always put these 2 modules on what's called the canvas here, and drop them in, and sort of like turning it on. And then similarly to Jeeva, after you've set up the IES files, then you can run a standard daylighting metric. For those of you who do know Radiance, this component right here is your ambient settings, and these files you'll see in a minute are just what you would normally do with your ambient bounces, your ambient you know, resolution, etc. That just translates into something that you input there. None of these slides are showing up very well. So this component is an IES Luminaire component in Honeybee. And it basically, what it needs to run is it needs you to tell it where the IES is located, where the IES file is located, and it needs the information about what points the IES files are at. So you basically set up a whole bunch of points in your model, and that tells you feed that into Grasshopper, and it tells it where each of those luminaires are located, and then you can tell it what orientation you want it to be, if you want it to be tilted, etc. Oh, I think I had these backwards. Yeah, I did. So this is a set of points that I put into the luminaire zone. And so these are the points where, this is what I was just saying. These are the points, every point represents one IES file. Then it has the spin, the tilt, and the orientation. So you can change those and put that in here. And then you take that information, and that goes out, and you can put it into this, where you give it the IES file. Once you've set that up, it looks like this. And this is another nice thing about Honeybee, is that it actually has the photometric files here. So you can see what they look like in space and whether they're oriented properly. And then after a whole bunch of more complicated stuff, this area is about setting up the materials for Grasshopper. So you can put in your geometry and then create a radiance material for that. And this is, like I said, is your ambient bounce parameter. And hopefully when you see the presentation, these should be high enough resolution that you can actually look at them. I really intended this to be a kind of guide so that you can look at it later and actually follow this step by step and figure out what, because I just didn't figure there would be enough time to explain everything in super long detail. But you should be able to look at this and actually follow it step by step. And if you're familiar with radiance, you should be able to recreate something similar on your own. The last step is the daylight simulation. And it's called daylight simulation, sort of going back to that point I was making about how daylight gets a lot of the attention and people don't think about simulating electric lighting and all. So you actually have to use the daylight simulation tool in order to feed all this information in, and then we'll run the simulation and produce an image, which you can get here. So it looks very similar to the one in Jeeva, but it's produced here. So then I think the last thing I just wanted to talk about is what is on the horizon in terms of what we're looking for going forward. And so I don't know how much you guys have heard about virtual reality environments at all. Anything? Yeah, a little bit. So this is just something we're starting to play with, and we actually generated it using pure radiance and not using any other features. And there's information on the radiance users group about it. But let me see if I can get this to work properly. Oh, it's like this. I'm doing it wrong. I knew I was going to mess this up. Oh, is it this way? No. It's the cardboard that's the difficult part, not the, no, that's not it. Oh, it goes this way. That's what it is. So just using your iPhone, you can actually, there we go. So I'll pass this around. You can actually see the radiance renderings. We did both a daylight, a luminance rendering, and an electric lighting rendering. It's just a still image. It's a omnidirectional stereographic projection, but it allows you to view your radiance model kind of in 3D in virtual reality. And so we're really looking towards that as on the horizon as sort of where we want to go. In terms of where we're headed. There's also a game developers engine called Unity, which is increasingly being used in the architectural environment to simulate daylighting and electric lighting, as well as any myriad of other things. And so we're also looking to try to expand our opportunities in that to really make buildings. I mean, all of this is really going towards the idea of making our building environments prior to construction, when they're in design, make them more sensible, right? In the sense that you can sense them better, right? You're going to have a better sense of what is going to be glary, what's going to be, you know, a problem, what's going to be a great appealing space, etc. So, so that's on the horizon, and that's it. So, thank you. And if there's time, I'm happy to go through Jeeva and show you guys the ins and outs of that.
I know that it's a little after 1.
Oh, okay.
People that have to leave, really, if there's interest, you know, for Eric show any more, then what's the consensus? Do you want to see any here?
I do a bit from top up. It's really
Yeah, I don't have a lot more to say. We're just getting our feet wet on that, but it's pretty fun. Yeah, or if you have other questions.
Yeah. And if you do have questions, the microphone.
Oh, the microphone.
Here.